I cheated and I lied. So I don't want Roger to be associated with geoengineering. I'm actually doing a PhD at University of Colorado, and I'm focused on geoengineering. So, in climate policy. So what is geoengineering? It's the deliberate, large-scale intervention in the Earth's climate. And so basically what they're trying to do is to moderate the current climate in the event that the climate gets too warm. So there are two main thrusts to this. So there's solar radiation management, and there's carbon dioxide reduction. Carbon dioxide reduction is a little bit about what Ben was talking about. So it's actually taking carbon from the atmosphere. So here are some examples. So there are some technical processes that are in the works, but it's brand new. It's pretty new. It's expensive. There are some natural processes you can do. You can do afforestation, so adding plants, which will increase uptake. And then there's sort of an in-between thing, ocean iron fertilization, which is probably not going to happen because it's a little bit scary, as is much of geoengineering. So next I'll talk a little bit about solar radiation management. This is probably more likely to take place. There are a couple of different techniques. One mimics the effects of volcanic eruptions. So there are aerosols that go up into the stratosphere and they reduce the amount of incoming solar radiation. John Latham, who is at NCAR, had this terrific idea in 1990 about creating clouds over the oceans in particular areas. And again, it reduces the amount of incoming solar radiation. And then there are a couple of other brightening schemes that I won't go into. So there's a real push right now for research that's going on. In 2009, the Royal Society had a report that came out, and that pretty much started this whole advocacy for at least doing the research, not necessarily the deployment, but doing the research. In 2011, the U.S. got into the act. The Bipartisan Research Council published a report, and these are some of the North American proponents of research. And these are the ones I know better, and so I don't want to implicate the ones elsewhere in the world. So there's our guy, John Latham. So everyone, the reports and everyone is saying, that there's the caveat that we should do the research, but geoengineering can't take the place of mitigation. We have to mitigate if we want to solve the climate problem. So there are also lots of opponents to geoengineering, no surprise. Probably the most powerful one is a civic society organization, the ETC, which is a Canadian-based group. They're rallying quite a bit of support. They went to the Convention on Biological Diversity meeting in Nagoya in 2010, and they got a moratorium on geoengineering, both the deployment and the research, although it's pretty weak, so who knows what will happen. One of the major scientists who's against it, who's pretty vocal, is Alan Robach, who was visiting here last year, and Jim Fleming is a professor, is a historian in Maine, who's also a big opponent of it. I think I said proponent, but they're all opponents. So right now, the focus really is on SRM because carbon dioxide removal, it's slow to act, it's expensive, and the technology is really, it's in its early stages. The benefits, unfortunately, SRM is the more scary approach, but it's cheap. It would cost approximately $1 to $8 billion annually, which, believe it or not, is inexpensive. It's fast acting. Either the stratospheric aerosol loading or the marine cloud brightening could happen within about a month. So the big issues, which many of you guys know, is the climate is a complex system. So we're really dealing with a lot of unknowns. Some of the things that we do know is that stratospheric aerosol loading is going to have some negative effects on the ozone hole. It's going to change the precipitation and temperature patterns, which will be potentially have horrible implications for the monsoons. It doesn't address issues like ocean acidification, and really the biggest problem is there are so many unknowns. Of course, there are ethical issues, the questions of equity, who gets to decide, what temperature we're going to be at, who's going to pay, who's going to make the final decisions, who talks for future generations or inanimate objects like the soil, the animals. There are other issues, moral hazard. Well, so what if we do this? Then are we going to mitigate? Probably not, realistically. I mean, we're humans, right? And we tend to take the easy way out. And then, so if we've got this sort of technology, will we implement? Again, I think that the odds of that are pretty high. So there were some people that started thinking about, well, so what are the things that we need to do before we do research or before we do deployment? So the Oxford principles is what came up. So public input is going to be critical, and it can't be a hand-wavy sort of thing. And odds of that are high that it will be. We need public input, we need transparency, we need independent assessment, and it has to be for the public good. Anyway, so my conclusion is that, so it's the early days of geoengineering discussion, and we really need to have a conversation now.